Thank you, Francesca. Nice to have you here. Well, it's on Bonaire. We're having the workshop on Bonaire, and Francesca's going to tell us how it is.
I'm getting home.
Yeah,
Yeah.
opening thing
With you. Thank you, Lisa. And there was just saying, good luck with your presentation. I feel I need it because after the presentation on sexual reproduction, to keep it equally exciting, just by default is going to be difficult. But I'll do my best. And so I'm Francesca Virdis. I'm the managing director of Reef Restoration Foundation Bonaire. Tineke, the DCNA, sent a survey before the workshop to test the interest of the audience. We realize we have a very diverse audience, not only here but at home. So it's kind of tricky to kind of decide the two presentations I was going to give, and I tried to follow what were your preferences. So this presentation today will be about fragmentation and in-situ nurseries, kind of the basic of what we have been doing here in Bonaire. While tomorrow will be probably more geared toward people that already started a restoration project and want to bring it to a different level, to a larger scale. And I'm going to share all the set of indicators, of performance indicators that we adopted to have a better grasp of our production when we talk about large-scale production. You know, all of these indicators that provide us valuable information to better strategize, plan for successful restoration on larger scale. But let's start from here. First of all, Reef Restoration Foundation Bonaire is an NGO non-profit organization founded in 2012 with the goal of assisting the natural recovery of coral reefs using active restoration. We propagate corals using two techniques. By now, we probably know which one they are. It's fragmentation and coral breeding, larval propagation. Using these techniques, we propagate thousands of corals every year that are planted back to the reef. The goal there is to boost resilience, establishing populations that are self-sustaining, sexually reproducing, and diverse enough to better cope with environmental changes, with emerging stress strength. But before we delve into the fragmentation world, please allow me to open a very short parenthesis because this is really an important part of who we are. So we are a community-based project, meaning that we're very proud of the relations we established with the local dive shop. Actually, as of yesterday, 2 days ago, we have 15 local dive operators that are members of our organization. What we do through this membership, we train dive shop staff, dive shop instructors, so they can train visitors and residents to become volunteers for our organization. So they are our center of education, center of training, first point of contact if you're coming on the island, you want to know more about the project, right? We're a small organization, we cannot reach out to as many people, right? Or the number of divers that are visiting Bonaire every year. So the partnership with the dive shop for us is great. We educate them, they help us to educate the rest of the, don't need to touch this. To the rest of the people that are visiting the island. And it's kind of a win-win, right? We also work in schools. I'm also proud to say that finally this year we managed to have coral restoration as part of the curriculum in the SGP group, so high school in Bonaire. But we also organize tailored experience for visiting students, local students. We work with local groups as we really try to have the local community involved so they can be our ambassadors, right? We don't want to be the people going out there and talk about this. We want to have other people to talk about this while we actually do the work out the water. So again, we value partnership as much as research collaborations because we are farmers. Our goal, and I really stress this out in particular for people that are approaching restoration, if you're a practitioner, the tendency of the beginning is start doing research and a lot of data collection. Don't go there. There are actually organizations, institutes, universities that they do that, and they do very well. So, but if you're a practitioner, your goal is to restore, keep your focus there, and through partnership, they can answer the question and they can inform you on things that you want to know. You can guide their research, and they bring together with us, that we contribute together to moving. I think it's me. We can contribute together to increase knowledge increase, better understanding of the overall reef restoration fundamental science worldwide. And here's some of the organization requirements. So, but let's delve into in-situ nursery topic. So a little bit about our in-situ nursery system. Currently, we're working on 12 different coral species. We have 116 different genotypes that are currently hosted in our, I think it's a video setting where the slides are moving on their own. Yeah, so we'll need to fit it on the next presentation. Yeah, I will go back every time. We have 116 different genotypes that are hosted in our nursery currently. We have 13 nurseries and about 256 units, meaning trees, ropes. We call it units like a component of the nursery, right? And more units form a nursery. So nursery are spread around the island, mostly on the west coast, some on the east coast, and some at Bonaire. We differentiate between production nursery and training nursery. Normally, training nursery are smaller, very accessible because they are mainly used by the dive shop to train divers. So they still produce corals and outplant corals. I'm sure if you have, for example, the opportunity to dive a Buddy's Reef, that's a training nursery, but you can see the result just looking at the plant there. They have the main difference is that they're outplanting a little bit of corals every week, while with our production nursery, we massively produce corals to restore target areas, right? And we will talk more about that. The overall capacity of our in-situ system at the moment exceeds 23,000 corals that you can count at any given time. Have the water there, and this nursery system allows us to currently outplant over 9,000 corals per year back to the reef. Okay, but let's start from the beginning, the harvesting, right? Where did we actually harvest the original colonies? We kind of follow guidelines, although I have to say 12 years ago, there were not many guidelines out there. The idea is to source corals from the reef. You had to at least say 100 meters far, when you pick your sites. And that's what we did with the permit that allow us to collect about 200 small fragments of Acropora cervicornis and Acropora palmata. We prioritize on corals of opportunities, so fragments that were already loose and rolling at the bottom. And also corals at risk, like the one that you see over here, like a coral that is partially dead, the extremities, the tips are still alive. They would eventually grow more, break out probably, and become corals of opportunity anyway. So we trim off these tips and brought them to the nursery. But recently, we had also the opportunity to harvest the different colonies, and that, for example, happened, and you will see it in the next slide, all the different details. But this, in particular, you see, oh my God, that Pseudoriflora strigosa is actually very good looking. Was it rolling? No, it wasn't rolling, but it was located under a construction site in town, where the environmental condition were going to change tremendously, because suddenly that area was going to become a completely shaded area with a lot of turbidity due to the construction materials. So Sinapa contacted us and was like, guys, if you want to rescue actually some of this colony, you want to bring in the nursery, I was very happy to do it. Also because that site was highly affected by Schedule D, and the majority of the colonies was already dead. So this guy definitely showed a lot of resistance. It was very good looking, performing well in the dirt, I would say. And said, I need to have that genotype in the nursery. So we went there and brought it there. So, but in general, first rules should be prima non nocere, means like don't hurt the reef, right? So when you are scouting or sources your colonies, we source everything locally in Bonaire. At that time, in particular, when we started, the idea of sourcing colonies outside Bonaire wasn't even an option. Like, also people were like super scared about outbreeding depression and all these kind of things. Also, what can happen if you bring corals from abroad? I think it's still a touchy topic, right? To move corals from one country to another. But unfortunately, we are not in the luxury situation, or in particular other locations in the Caribbean that can say we have such a high diversity that we don't need colonies from abroad. Unfortunately, as you've already heard during the introduction, there are reefs around the Caribbean where the reefs are highly decimated, and an option like probably sourcing from abroad, it became over the years much more a realistic option, and maybe sourcing from colonies that are more heat tolerant, for example, from locations where the corals better withstand different temperature ranges, right? So it moved. So what I'm going to talk about. Of course, I always suggest to try to source from different gradients of depth, visibility, turbidity, anything on your reef. So before we actually go and grab the colonies, and source anyway our corals, you really need to know your reef and try to source this colony from all the different conditions, right? Before bringing it to your nursery. And that's what we did. And this is Bonaire, and these are our source site, our harvesting site. Like I said, we started with the branching corals in 2012, and then 2019 we were allowed to bring 3 species more, 2 Orbicella species and Taster cavernosa. So we actually sourced from 8 additional sites. And then between 2015 and 2020, there were several occasions where we had both grounding and storms, and Stinapa again, the park authority said, hey, if you want to go there and maybe rescue some corals that are rolling at the bottom, please feel free. And that allowed us to increase our gene bank diversity. And then there was last year. Last year, 2023, I think was a pivotal year for Bonaire, because it was the year that where Scattered Leaf was firstly recorded in Bonaire, March 2023. And then we decided together with Stinapa to start this gene banking project, right? Like going around the island for over 3 months and really looking for colonies that exhibit some sort of resistance to the disease. And then while we were doing that, also bleaching arrived, probably the worst bleaching event we ever experienced in Bonaire. And that was a terrible situation. But unfortunately, if I have to find, let's say, the silver lining, I have to say allowed us really to look at the reef and say, oh, this guy is very strong. This guy is very strong, because if they can survive and they can actually exhibit such a strength in this condition, this genotype is very strong. And so that's why we started adding species and diversity and genetic diversity to our gene bank, adding 7 different additional species. In our gene bank also, we have our sister recruits. So these are kind of the product of our coral breeding effort. They're very tiny. You will see pictures. I cannot still call them like Brusto because they cannot be fragmented yet. But if they survive, hopefully one day they will be actually the new parent colony that we will use to further fragment in our fragmentation process in our nursery. So we add in diversity to our gene bank using our coral breeding program. And here we go. I'm sure you're familiar with it, but please bear with me because I know there are a lot of people that don't know much about coral fragmentation. So I thought it was important to show, for example, this is an original parent colony that we harvested from the reef in 2012. And then, you frag it, you just cut it like gardening. And then in 13 small pieces, about 5 centimeters long. And the red bars indicate the 5 centimeter of the original length, and that's what happened in 5 months, and this is what happened in 9 months. And this is to show that some species actually grow very fast. A lot of people feel like, but restoration could be fast enough. It really depends, because there are species that you will see it also on our outplanting. Some species really grow fast, and you can see results in a very short time. Let's talk about nurseries. So we have 2 different type of nurseries, centralized and decentralized. There are pros and cons, so I'm going to go through those. So an example of centralized nursery is our nursery at Klein Bonaire, located in between Johannesburg and Brockpile, the name of the dive sites. Centralized because corals there get dispatched, let's say, by boat to the different outplanting sites. Pro is that you can pick that site and choose like the best condition you want to have for coral growth, right? So originally when we picked that site, we thought, okay, Klein Bonaire probably is a little bit far from, runoff from the main island. It's kind of a shelter from, the major direction of the big winds and surge when we have it. Also, there is a nice still wild patch of stubborn coral nearby. So if the wild population is still thriving there, probably the corals in our nursery are going to do well. Also, not exactly at dive size, so not so popular, but in between, where there is no mooring on the marine park. Actually, Stinapa put a mooring just for us, so not so easily accessible. So again, a centralized nursery allows you to pick the best conditions for coral growth. It's sort of not a good thing that you need to dispatch corals because, of course, you can pick the planting sites, but that means that you need to transport corals by boat. And that's a stress for corals, right? Unless you put in place and you kind of make the logistic a little bit more complicated with paddlers and stuff like that. If you want to keep it simple, you need to keep the transporting time very short. We were not sure how short, right? Like how long can we transport corals? So that was one of the first little study research that we did, I think in 2014, where we start transporting coral for different time and bringing them back to the nursery. Different genotypes transported by boat, by car, wet, shaded at different times. And we did it only once, right? So we did it for a certain condition, like a season that was summertime, right? But probably the condition would be different if we repeated in a day that would be hotter or more humid, but at least to have an idea. And we realized that if we keep our transporting time below 30 minutes, there was no stress whatsoever on our corals, right? Regardless the modality of transportation. I'm not saying that this is a result that would work for everybody around the world. There are people, there are projects that are forced to transport their corals for an hour and a half, 2 hours, 3 hours to reach our planting sites. Also, projects that because of the season, not very forgiving, they need to outplant everything in a day, right? So they need to transport for longer time in bigger quantities. This is something that works for us. So when we pick our planting site from our centralized nursery, normally we never pick a site that will be further away, 30 minutes. We also transported by car because we were thinking that maybe the vibration would be different because when actually transported by boat with waves or also by car, you know, let's see if vibration could be some sort of impact on the corals. It was kind of funny driving around the island with corals at the back of the pickup truck for 20 minutes, 60 minutes, 80 minutes. And people are wondering why I had corals at the back of the pickup truck. I even stopped refueling the car that day. I remember that people were like, I need to keep running, sorry, for another 20 minutes. Anyway, so parentheses, that sometimes can be fun. Of course, transporting corals far away requires some complex logistic, and it's a limit because the limit is how many corals can you put on a boat, right? And the more corals you put, the less people you can transport. So you have, if you fill your boat with corals, then you have less people that can allow you to outplant it. But then you can go back and forth, right? But what if it's a 30 minutes far away? So this is just to say that it's a little bit more complex logistic. Also, you're transporting corals to a site that has inevitably different conditions than the nursery. So corals, once you are planted, they need to be acclimatized still, right? Because they didn't grow there. And although we're still in Bonaire, every site has different conditions in terms of nutrients, independent water quality, visibility, and so on. On the side of risk management, also, you cannot put in all your eggs in a basket again because you have one large nursery. And what if you have a storm there? You're going to lose everything, right? So that's why we also use decentralized nurseries. So nurseries that are located at the outplanted sites. So when we establish a site that we want to, is kind of target for our restoration, we place a temporary nursery there. So corals are produced where you're going to outplant them. So they're already acclimatized because they grow there. Also the beauty, you don't need transportation, just swing from the nursery to the planting site. So there is no limit. You just go there for a day and keep going back and forth. So as many people you can have, you keep going all day. So you don't have to pre-plan, okay, today we're going to move to 100. You keep going. You might actually surprise and you may do 600 in a day. So it's easier in terms of logistic. It's less stress on corals, as I said. Monitoring maintenance, though, a little bit more complicated. Now, instead of having one nursery in Bonaire, we have actually 13. So when you have to monitor and maintain them, it requires much more work, right? And you need to use multiple teams. The side of risk management works better because now you can replicate genotype at different nursery in different locations. And if there's a storm coming, a particular disease, you're only using replicates. So you're going to use part of your gene bank, it's true, but they are replicated somewhere else in another nursery. So it's easier. Okay, so we use different designs. we are not, there are people like, oh, we use trees are the best, and we're not that kind. We try everything and see what it works. We feel like that the more tools you have in your toolbox, the better, because there is no one fits all, right? So we started definitely with the trees. The trees are great. Hanging corals on the tree, or you see the second one, this is a tree nursery. To host boulder corals, because you cannot hang, you can hang boulder corals, but we prefer to have it on a flat surface because of the morphology, and then it helps for the outplanting. But we also use ropes, and I will go through a little bit what are the differences, both vertical and horizontal ropes. Pros and cons, like I said, trees definitely accommodate for different morphologies. They are long lasting. Imagine that last year, actually, we kind of disposed some of the trees that we placed in the water in 2012. So, and that's what you want, sometimes I hear like, oh, maybe we should use a biodegradable material, but in reality, the purpose of the nursery is to stay there. So actually for me, the more it lasts, the better. For us, any, vertical nurseries kind of an increased capacity as well, if you can take advantage of the verticality, and in particular, the trees have a very high capacity of tree or tray trees. They all host more than 100 fragments. But because you have these structures, they require also more maintenance, cleaning, fire core removal, algae removal. So there is some maintenance to plan if you approach this kind of design. And sometimes you also need to move them out of the water to completely refurbish them. And that's what we call the downtime, right? That unless you bring another tree in, then it's a moment of no production. So it's the downtime. And then we have the ropes that we introduced about 3 years ago. Vertical ropes, horizontal ropes, and that's the flexibility that you can use it vertically or horizontally. So for example, this is our nursery in Lac Bay, 1.5 meters depth. Definitely I couldn't install a vertical nursery there. So we decided to adopt this horizontal variation. They can host a limited amount of coral though, at least for our depth. They always below the 100 fragments per unit. Less maintenance because corals overgrow the rope, so you don't need to clean the rope. Actually, the corals kind of protecting the rope itself. So because they kind of self-cleaning themselves because you have the coral overgrowing, you also don't need to bring them out of the water. So there is no downtime there. Okay, so let's delve into the coral chopping or fragmentation. So because a lot of people I know a majority of you are familiar with the branching corals, right? Which is quite easy to fragment. But so I decided to kind of gear it more towards the fuller corals. And here you see the process. So of course, we first source this coral from the reef. We don't do it every time. We do it just once. And then we keep fermenting from the coral, from the broodstock that we have in our trees, of course. So this is an example of a colony that we sourced last year. You're Schedule D, so Dicosinus stochastic. And you fragment it. You cannot do it. Colonies, they are so big. You need to use a saw, right? And we use wet tile saw for these large pieces, and it works quite well. And then from there, we create our broodstock. So our parents, let's say, and the broodstock each fragment get glued on trays, on cards, on land. And the trays are placed underwater. And this is what we're going to do together on Wednesday, right, during our second field trip. So we place our broodstock on the tray and we let them grow. It really depends on the species, how long it takes to get to point. Some species grow faster, but I would say it takes maybe 10 to 12 months to reach that level. So they grow slightly slower, of course, than a crop row or branching corals. And then once the broodstock reach that size, you fragment it again. And for this microfragmentation, because we create fragments that are like 1 to 5 polyps, let's call it microfrags, we glue them on plugs. These are the corals that will go on the reef. And one of these pieces will go back to the card and repopulate the broodstock, right? So that's why I was saying we don't go back to the reef. So once in the plugs, we let them grow again. And it would take again maybe a little bit less because the plug is smaller than a car to reach that size. So maybe 7 to 8 months. And then once they're ready, we plant them on the reef. How? So we create mounds like coral head with cement, and then we plug them in. So of course, the size of the mound and the distance within the plugs is different depending on which coral species you're trying to replicate, right? Some corals, like for example, Orbicella annularis, it's more like a low, right, morphology. So each plug can be a little bit more distant from each other. So while, for example, Montastria, they are all very tight together. So the mound is a little bit smaller, and we try to make a product that is like smoother since the beginning. I always suggest look at the corals and how they grow in the wild. That will be the best teacher, right, for you. But also not only how they grow, but where they grow. And I give you an example. When I first learned 2010, actually, Kennedy Meyer from Florida Keys came here and started teaching us like outplanting techniques. They were using epoxy to secure staghorn corals at the bottom in Florida, right? Because in Florida, they have rocky bottoms everywhere. And I was like, okay, great. And then he left. And then I started looking around and I realized the staghorn corals in Bonaire don't grow on rocky bottoms. They are all on the sand. So I was like, so how am I going to secure these corals on the sand? So you will see it, but this is like saying that there is no one fits all. I will talk about a planting technique, and the best way is just look at how your reef in your local area look like, right? Going back, sorry, kind of skip some steps to the microfragmentation. You will see, because you will be part of this madness. It requires a little bit more logistic, because now you're cutting corals out of the water. Unless you have aquarium tank, In-situ, that I really envy, Jamie, you need to figure it out. And sometimes, we don't have also a lab, so we need to do where we can do it. Sometimes we ask Dive Shop to use their docking area, their platforms, our office, not my kitchen, thanks God yet. But the important thing that you can keep them out of the water just for a short amount of time, right? And so there's a lot of thinking, and you will be part of this process also on Wednesday, like how we can quickly cut, keep them wet, keep them moving so to make sure that they get back to the nursery efficiently. Okay, so let's talk about outplanting, because at the end, this is the most important part. We can be successful, great in the nursery. We can produce thousands and thousands of corals, but if this one don't survive after you are planted, it's kind of, you learn a lot, and we all need to go through that process of learning, but it's very important that you measure your success on the reef. So a little bit of our outplanting and restoration site. Currently, we have 19 outplanting sites. 12 are target for restoration. The other are used mainly for training, as I was explaining the difference before. We have outplanted back to the reef about 61,000 corals now, excluding what we produce through our coral breeding program. So if we can measuring our restoration area, like in all the outplanting sites that we have, all the outplanting plots, as this is like a metric actually that the Coral Restoration Consortium invited all the practitioners to use. So the restoration area is the area that encompasses all your planted corals, right? So adding all each of our planting sites together, each of our planting plot, we exceeded the 13,000 square meters at the moment. This is an example, one site, Jeff Davis. This is when we finished the outplanting. 2018 was the last time we outplanted corals there. About 3,000 corals were planted there thanks to the support of and the funding of the Dutch ministry. At Jeff David and another 3 additional sites. This is how the site looked today. You can see in the first picture all the different cluster, all the different genotype, and then how they fuse together now, and they look more of a thicket. And this is how it looks underwater, which is pretty. Oh, there is like half of the presentation missing. It didn't get copied, maybe. Should be there. Oh, here you go. Maybe it was copied 2 times, and the second part actually is here. What? We got it back in. No panic. Enjoy the corresponding after this. So we have been witnessing this corresponding since 2017, and also with support. We went there in the past couple of years and being able to collect. For us, having this sort of mass spawning at the site, I think is already kind of benchmark of success. If you think about the original goal was to establish core population that are self-sustaining and sexually reproducing. So this is what it is. And also, you know, sometimes there is this, no, I wouldn't say a misconception, but sometimes people think, okay, with fragmentation, you are actually not increasing genetic diversity, right? But at this site, you have 11 different genotypes that are spawning simultaneously. And so we're still facilitating cross-fertilization there, something that in nature, as Kelly said before, very unlikely is going to happen, because in nature, these patches are all monoclonal and they are so far apart that would never actually mix. So, yeah. And this is not just Jeff Davis, but the same is like, this is another site, Carcil, about 2,000 corals are planted there. Last outplanting was in 2021. So also corals here have been spawning. We actually were able to collect last year. You can see, for example, in the first picture on the top left, this actually colony is a cluster. Those were originally five corals that fused together. You can see in this shallow area, first thing they do, they try to enlarge their base, kind of becoming more solid, and that's why we are planting cluster. Because if you plant a single colony, then there is a high risk that as soon as they grow, they flip, right? While if you plant 3 to 5, they kind of work together, fusing and becoming a more solid structure quickly. In particular, like in this shallow area, they tend to grow immediately wider and more than taller. Like I said, different planting techniques, no one fits all, depends on your structure and your conditions. We have been using a lot cement. We don't use any more epoxy. We feel like it's more forgiving. You will see it this afternoon. You're going to plant with us. It's also cheap, available, which is an important part of the thinking when you talk about large scale and a small island or remote island. It works very well with different coral morphologies. Like I said, when we started, there was a lot of sand around and we couldn't glue stubborn corals on the sand. So we started using bamboo to provide like an initial structure where we could tie corals on, and bamboo is biodegradable, and it worked quite well. But little by little, we also abandoned the bamboo. Again, just looking at what nature is doing, I was like, why do we need to secure corals if in nature they grow on sand and they're not secured? So what is the trick there? So we started looking at planting site, and we realized that actually corals are wedged in between fire blade corals, and they kind of grow and wedge each other and grow together, fusing and kind of self-stabilize themselves. And that's what we started doing. We are keeping corals for a longer time in the nursery, so they become bigger, and then we can really wedge them between each other and between fire corals or other natural feature to stabilize them. So we don't need to go towards like artificial reef strategies. We will talk about monitoring tomorrow and photomosaics, but this is a photomosaic of a site, Point Virkan in the south of the island, over 1,800 corals there. Are planted, and this is like how photomosaic can also help you to, for example, track how your genotypes are distributed in a site. And this is a very important information. For example, when then you approach coral breeding, you need to know where are you collecting, right? So having a map like this to show you how originally you are planted there is very useful, in particular because we know underwater tags, plastic, not very good. Also, not long lasting, regardless. I don't know, I didn't find the magic tag yet. So what we do after a year, we actually get rid of tags after we finish the water survey, and we will talk about that tomorrow. But we use images, right, to keep tracking our colonies. Okay, so here, well, up there is reading fragmentation. I just want to open again a very short parenthesis. The fragmentation and collaborating are not necessarily so different or far apart. I mean, not saying they're the same, they're fundamentally different, but they, I think, are very important techniques if you use them together. So I think they're kind of the two sides of the same coin, right? And a lot of solutions that we, or things that we learn doing fragmentation, we can now use it applying to our cooperative program and vice versa. And I will give you some example. First, as Kevin said, Davis, we said 11 different genotypes. We were able actually to go there and outplant a different area of the same outplanting site and have different genotypes. Actually, we did the genotype testing of our genotypes. So all the corals that we have, if we say different genotypes, are actually different. Yeah, and this allowed us, well, simplify logistics for sure, because we could collect from all these different genotypes, but also kind of open to research opportunities, right? Because you can also do target collection, deciding which genotype you want to actually mix. Or, for example, inspire collaborative approach, like the multi-colony collector of Secor, because we're saying, but why if there is so much spawn everywhere, we just don't bring big tents, right? What we're gonna, I feel like I'm trying to collect it with a spool here. I need a bigger tool. There is much more spawn there. And that's how the idea of the multi-colony collector happened. And maybe now not be so ideal for the situation here in Bonaire, because I still would like to move it a little bit more. But you heard it from Kelly that from there, it actually inspires or spearhead a further application of the collector. And also what you learn in your fragmentation process, as I said, can be used in the coral breeding. And this is an example. These are actually on that tile, you don't see it on the substrates, but there are a lot of hundreds of young settlers that are product of our coral breeding effort. Instead of outplant them all on the reef, we decided to introduce an intermediate nursery phase and to see actually our nursery can help the little baby to reach like the recruit stage and become bigger. And so this is actually one of our nursery tree. And this is the corals. This we took the picture a couple of days ago. These are 1-year baby Coprofilinations that we produced last year as part of our coral breeding efforts. And even more, so this is the horizontal nursery we have is very similar, that we have a lab, right? And together with Kelly, we were brainstorming, well, if we want to introduce a nursery phase, what about you put the tent, pour your larvae in, and instead of using just the crates as you always have been doing, you actually create already a nursery there, and then the settlers will happen on the ropes, and then you can just flip the ropes and create a nursery out of it. So this is to say, this is kind of design that we already use in fragmentation. So we were very familiar with it, and we knew a lot about the maintenance or how to build this kind of structure. This is just to say, like, that we really love how the two techniques actually can benefit from in the application from each other. And at the end, just to say that we have some goals from this year. We want to extend our capacity. A list of 20%, at least to bring it toward almost 25,000 corals nursery capacity. We want to add 2 species more, working on Celluliparus glyvosa, which we don't have in our nursery yet, and then we didn't target for the coral breeding, but definitely has been affected by Schedule D. Together with Secor, we're actually starting a new project with Millepora complanata, fire corals, because fire corals, as I said, is quite critical, we said, in the preparation of the restoration site. So if we have more fire corals, that will help us to outplant the corals, right? So that's just at the beginning, but it's together, we were working together with Secor. We want to expand our gene banks, seeking more colonies that are resistant or show some tolerance, for example, to bleaching on the reef. We are testing shading option because last year, of course, bleaching was very bad, and at least we want to make sure that we protect our gene banks. Last year, we brought them to deeper areas, but of course, while bringing maybe bolder corals to deeper areas, it didn't really affect the corals, while you bring in maybe a proper corals of 30 meters that they are not very used here, definitely had also an impact on their growth. So we were testing like different options, and testing, for example, the different growth at different depths and with different shading options. And then, of course, as I said, our goal is to bring corals back to the reef. So as long as we keep going and testing new things, but we want to keep outplanting corals. So that's why our goal is to outplant over 9,000 coral this year as well. And that's it. So I want to thank DCNA, of course, again, for the opportunity for hosting and hear some of the funders and supporters of our project and partners that allowed us to continue to do what we do. Big thank you. Oh, yeah. Yes, thank you very much. Are there any questions from the audience?
So we were snorkeling up in the north yesterday, and pretty shallow. There was probably 5 or 6 genotypes of Pista. One of those has got Skittle D, the other 3 haven't, but they're pretty large. How do you, with your starter, your genotypes, are you removing whole colonies? And if you've got a massive colony, what is your approach to slicing that up?
So for now, we were able to find colonies that are also smaller size, so we don't go and harm corals that are large and probably are already spawning naturally. So ideally, because the priority is not harm colonies, we won't touch these colonies unless, for example, some of these fish colonies have still a portion that is dead, and sometimes that tissue separate to living part, then we can still frag it there. So you are not actually harming the living tissue, you're just kind of breaking it where it's already dead, and then we can extract like a portion. So we prioritize smaller colonies. Of course, I don't know what will be in the future, right? If these colonies won't be available to us, we will have any way to discuss this with the park as well, but you can always core it. Yep. We have also drills. We did it in the past, originally, I'm talking about probably 10 years ago, we did it on some colonies. It's definitely not our preferred way. It's very harmful. And although some of them survive, you still need to close the hole with epoxy. I mean, you're hurting corals in a moment where I think we should not. So I would rather always source something that is already loose, and still in Bonaire we have a lot of them, instead of going and hurt these corals.
So you mentioned that you collect corals that are very resistant, for example, from turbulent waters.
Yeah.
I know that they did some studies by cross-transplanting between environments, and then those are not always the corals doing greatest in clean water. Did you observe that too?
Yeah. You never know, right, how corals would react. And initially, I thought that corals that were performing very well in the nursery would also perform greatly after outplanting, and it's not necessarily. You learn a lot after the years. How your genotype are behaving in different environments, also because we replicate them in different nurseries. We'll talk about this tomorrow, and we outplant in different outplanting sites. So we know what works well where. But for example, last year when we started scouting and finding this colony extremely resistant in one side, then we moved it to, for example, something special. Well, we had another golden nursery and performing well. The only thing that bleaching arrived, and we moved it slightly deeper, and we thought, okay, other than that, we didn't change anything. In reality, it's something special. There's sort of water circulation there with the marine, and as soon as we move them out, because in Bonaire, as soon as you move them deeper, you're also moving them out, you could really see that a lot of algae started growing and getting trapped in the nursery, and we immediately moved all the corals to the north. So there are so many components of every site in terms of environmental condition that it's very hard to predict how corals would actually respond to that specific local site. Of course, with experience, you kind of try to predict it, but again, you see last year, I thought that would have been good, and no, but as long as you have indicators in place and ring the bell, right? That will like, oh, this is not going well, you need to do something, and we will talk about that, because when you have 260 trees underwater, it's not like you're monitoring 3 and you're every day there and say, oh, it's doing well, no, it's doing well. You need to have a system of indicator in place that will tell you, hey, something happening as something special, you need to make something there, because it's not only one genotype, it's across all the trees, it's across all the genome, it's across all the species. So it's not the performance of a particular species or genotype, something happening in the environment there, right? And also it happened, for example, at night, another nursery that we have, Outplanting Bonaire, always very well performing. Suddenly, I think it was 3-4 years ago, we saw mortality increasing across all the different genotypes, and like something's happening. And the same genotypes were apparently performing very well at the other locations. So what is happening at night that was not happening a month before? And then we talked, I remember at that time with Sinapa, and everywhere there was an increase of cyanobacteria in that area and increase of disease frequency. So we don't know what was the reason, maybe a runoff or something that came from the main island, but definitely something that we observed. So of course, sometimes can also be used as a kind of bioindicator of something that, sort of again, an alarm, let us say something is going wrong there. I don't know if this answered your question.
Yes.
Yeah.
So 2 more questions.
Yeah.
One Monique, and then do a lot of Jamie, then we're going to break.
Yeah, did you lose a lot or some of your outplanted reefs in 2023 due to the disease or bleaching?
No, actually not. We were very lucky. I don't want to say this now loud because we're going to face even worse conditions this year, but we were very lucky with our aquaculture in general in the nursery and the outplanting side. Of course, we saw a lot of paling, but we didn't have that much mortality that, for example, was experienced in Florida. Also, our outplanted boulder corals, maybe because of the size, because they were very small, like this size, they were able to cope better with environmental changes, because there is also, this again, we're part of a research project together with Secor on establishing, for example, how polar coral, they're smaller, like recruits, or the size hasn't make them stronger in a way. Maybe they're better able to shuffle, for example, zooxanthellae, but they're definitely survive better, the recruits, to the bleaching event. This was kind of the size of our outplanting. So far, so good.
Lastly,
Yeah, sort of linked to what Alan was saying, also what Kelly was picking up on the heterotrophic feedings. There's been a lot of work looking at how bleaching resilience can be boosted through heterotrophy, and high sedimentation areas generally show higher sort of tendency for heterotrophy and therefore better bleaching resilience. So when selecting sites, do you do any plankton surveying at different locations? Because you're considering flow patterns, light patterns, stuff like that. But do you look at the the biotic factors of feeding, and could that boost some local resilience within your nursery?
No, we don't get to that point of like studying this, but we have a planting more or less everywhere on the island. So we're based on our previous experience, right? And see what worked well there previously, maybe in a nearby area in terms of genotype performance. So probably we prioritize first, at least the one that are performing better. I'm not saying that we discard the weaker performing, because you never know, but at least to start with, the first one are always the one that are hardest. We want at least to start with the strongest one. So we base our choices on experience, and tomorrow we will see a lot more about this kind of indicator system we have in place to get constantly this phenotypic information from every site. So it's more based on how our corals performing than actually trying to get environmental information, right? Also because environmental information changed so much. And I have to say, you might do a study and then realize, okay, this is the water quality, this is the pattern, right? But then the next year, something gets built on shore, and then you have a hurricane waves passing there. So environmental conditions change again. So it's very hard to work on that. We definitely look at the water quality studies that the park are doing. And we talk also with the authority in terms of what's the plan for that area. I remember the first year was like, I want to restore the crocodile population in town. And I was very ambitious. And then I realized, why am I even doing that? Like, is the island on the same page? Do we want to actually restore the corals in town, or we're still building there? Are we still giving permission to build piers? Maybe that's not the priority for the island, and we want to create something that is sustainable and long-lasting. So maybe that was not a smart choice. So we need to work together. So that's why we had meeting, for example, with Wageningen and together with Tinapa, say, okay, maybe we should start here.
Thank you so much.